So welcome to part 2 on the video of imine and enamine formation. So part 1 I went over the formation of imines with a primary amine nucleophile. This part I'm going to talk about the formation of an enamine, which uses a secondary amine as the nucleophile. So for the formation of enamine, you have a reaction between an aldehyde or ketone with a secondary amine. So that is the big difference. It's a secondary amine versus a primary amine, which is used to form an imine. So an enamine looks like this. So rather than a double bond connected to the nitrogen, we have a carbon-to-carbon double bond. Now, of course, this is resonance stabilized, and that is one of the factors that contributes to its formation, is that it is resonance stabilized. It's just the neutral form will predominate. So I'm going to go through the mechanism of this now, and you'll notice it's a very similar mechanism to what you see with the formation of an imine. I'm going to use the same substrate we used last time with the aldehyde. Step 1, again, is a nucleophilic attack, but this time by the secondary amine. So it has 2 R groups and a hydrogen rather than 1 R group and 2 hydrogens. So following the nucleophilic attack, I have that compound. Next step is a proton transfer with the ammonium ion again. It's just this time it has 2 R groups on the ammonium ion, and the oxygen is protonated. Next step is another proton transfer. This time we're deprotonating the positively charged nitrogen using the nucleophile, or the same compound that was the nucleophile. Or that acted as the nucleophile. So there we go. We have our carbinolamine again, right? That is our carbinolamine. Next step is going to be another proton transfer. We're protonating the oxygen. To make it a good leaving group. So now that this is a good leaving group, the lone pair from the nitrogen drops down to form a double bond. We kick off the water. We do not have a lone pair there. That's a positive formal charge. So if this was the imine, all we would do is deprotonate the nitrogen to get rid of that formal charge, and we'd be done. The problem, though, is we have 2 R groups, so we can't remove the R group. Instead, we need to deprotonate from the carbon that's adjacent to the double bond. So what happens instead, I have my secondary amine deprotonates, and it can deprotonate here because we have resonance stabilization with that double bond. Also induction effects from the nitrogen. Both of those aid to allowing this deprotonation. The electron pair from the hydrogen-carbon bond goes to form a double bond, and it kicks one of the electron pairs from the nitrogen-carbon double bond up to the nitrogen. So we're left now with our final product. Now notice that in the entire mechanism here, it's identical to the imine formation until you get to step 6. Step 6 is what differs. Rather than deprotonating from the nitrogen, you're deprotonating a carbon because there is no hydrogen on the nitrogen. That's the only difference between the two mechanisms. So it follows the same exact 6 steps. Formation of the carbonylamine, formation of the imine. It's just this proton transfer here is the only thing that's different. What proton is transferring is the only difference between those two mechanisms.